Okay, so intermediate value theorem, real quick, just a refresher. We did a couple intermediate value theorem questions, but we did not finish the last question. So, intermediate value theorem says if there's a river here, and I'm on this side, fast forward, I'm on this side, what had to have happened? I had to have crossed at some time. When? I don't know. How? I don't know. But I had to have crossed, right? That's what the intermediate value theorem says. Okay? So we have to prove it, we have to show where I started and where I finished. And if it's above that or past that, then I'm good. So we looked at zeros, right? Zeros mean it crosses the x-axis, but it won't always be a zero. Okay? So let's look at number 3. Verify that the intermediate value theorem applies to the indicated interval. So this question is actually not too bad, but a lot of people see the X's and C's and F's and guaranteed and theorems, and they start to freak out. That's a wall, right? That's a wall. You got to keep going through that wall. You got to keep going through that wall, because if you actually sit and read it, you can understand it. Okay? It says verify that the intermediate value theorem applies to the indicated interval. We know what the intermediate value theorem is, okay? Using this interval, 0 to 3, inclusive, so from 0 to 3, and find the value of C guaranteed by the theorem. Okay. So let's start with this. What's f of x? What does f of x represent? Because right there, if you read that and I wasn't here to show you what to do, some of you would hit the wall. All of you would hit the wall. Some of you would keep going and be like, okay, well, I understand it. That's what I want. Some of you would be like, I can't do it. You can't do that. You can't have that. You cannot. You cannot expect in this classroom, like I said, to survive and to do well in this classroom, you can't expect Mr. Flores to do everything. You got to be able to do stuff on your own. So let's talk about it. How do we get through that wall? What is f of x? No. What is f of x? F of x. F of x. That guy right there. What is that? Not the y value. What is f of x represent in this question? The function, the equation, right? That's the equation. That's this guy. That's the blue guy, right? That's the blue guy. That's what the blue guy is, f of x, right? Okay. Now let's go to the interval. What does 0, 3 represent? Not 0, 3. What does 0 represent? Start with 0. What does 0 represent? It's not a point. What does 0 represent? What start? The x value. The x value of the start. So it's the x value for this guy right here. The x value. I don't know what the y is. How would I figure out the y? Plug it in, right? Plug it into f of x. Good. What does 3 represent? Not the y value. Yeah, Arthur? There you go. Okay. So talking this out helps, because when you hit the wall and you're like, I don't know how to do this, talking it out helps understand what doing. So far we know what we're talking about. Okay, so then we have this part here. That part right there. F of C. Well, let's go back to the question. What does it say C is going to be? C is what? What are the 2 words before it? Value. It's going to be a value, right? It's going to be a number. There's going to be a number there. There's going to be a number in there for C. Okay. Do we know what that is? No. Equals 0. What does that mean? What is 0? the y value. So 0 is the y value. Then what is c? The x value. So what do I have to do here? What's the question asking? We've gone through all the parts. What is the question asking? Okay, but instead of f of c and f of x, explain to me what that is. Kinda. You're getting close. You're getting very, very close. And you might actually be right on, but I'm just so what are we doing? Yeah, what are we doing? What do we know and what are we trying to figure out? Yes, that's what we're trying to do. We're trying to figure out what x value to make the y 0. Y value of what? X value of what? Hmm? Not f of x. F of x I know. I can plug in numbers, right? I can plug in numbers for x and that'll give me y. So f of x I'm not really concerned about. It's more of what? Go back to this picture because this is a good picture for it. So f of x is the blue. What am I trying to figure out? The x coordinate of what? You're trying to figure out that point right there. That's the x coordinate you're trying to figure out. Is it on the blue? Yes. But it's also where? On the line. What is the line? What is the line? F of x is the blue guy. What does the line represent? The river. Yeah, the river. The line is the river. So what are we trying to find? We're trying to find where they cross. Where we use that. There's a word we use in math. Intersect, right? Where they intersect. We're trying to figure out where they intersect. So what I'm trying to do is figure out that. And I know half of it. What is this half of this going to be? It's a bad picture because that's not actually where it happens, but this is the best I come up with. 0. We know 0, right? How do we know 0? They told us right here. They said the y value is 0. So I know my answer is going to be something comma 0. Something comma 0. So my question is, how do I find the x coordinate? Mhm. So what would that do? So if I plug in 0, I don't plug, yeah, I like how you said we don't plug in 0 for x because it's not x, right? Yeah, so that's what I'm saying. I like how you did. Most of the time I get students who answer, they're like, we plug in 0 here, here, and here, or here and here, right? And it's like, no, because it's not x, right? But why f of x? You're right, Arthur. Why? Exactly. We know the y value. So if I plug in 0 for x, that's gonna tell me a y value. I don't need the y value. So we want to find out where two things cross. So let's look at two things like this. Let's look at two graphs like that. You've done this one, not in this class, but long, long ago, right? Let's call this one f of x. Let's call this one g of x. I want to figure out where they cross, right? Here's the graph. Let's see, here's the graph right there. what do I do? There you go. Anytime you want to see where something crosses with something else, you always set them equal to each other. Always. It doesn't matter what kind of function it is. If you want to figure out where something crosses, you set them equal to each other. Okay? So I want to set the blue guy, which is f of x, equal to the river. What is the river? What is the equation of the river? 0. Yeah, 0. Y equals 0. Right? Y equals 0. That's the equation of the river. So I'm going to set this equal to 0. Very popular question on multiple choice questions. Very popular question on multiple choice. And most people see this stuff here, verify that, and then they hit the wall. Okay? Think about it. What does it mean? I have a function that goes from 0 to 3. F of c equals 0. Where do they cross when y equals 0? So in other words, this guy right here. This is x and y. So we know that, or we don't know. So let's say we're down here. Let's say we're over here. Let's say this is the river right here, because it says 0. Y equals 0. That's the river. So we want to know when it crosses. Could it cross multiple times? Could I do this? Could I do this? Right? Does it have to cross? We don't know yet. We don't know yet because we haven't even checked. So the first thing we should do before we do this actually is to check where it starts and where it ends. So where is it at 0 and where is it at 3? So tell me, where is it at 0 and where is it at 3? That's the first thing. Where is it at 0? Where is it at 3? So where is it at 0? 8, positive 8. Got a dot right there. Where is it at 3? Negative 1. So it does. It will cross. It will cross the river, right? It will cross. How many times is it going to cross? From 0 to 3. It could cross how many? What's the least amount of times it could cross? Once, right? Once. It could just cross once. Could it cross twice? How would that look? Show me a picture of how it crosses twice. Do a little sketch on your paper. How would it cross twice? To go from blue dot to blue dot. How would it cross? Show me a picture of something that crosses twice. You got it? Let's see. That's 3 times. You cross 3 times. If I'm trying to get to the other side, can I cross the river twice and be over there? No, I'm going back over here, right? I could cross once. If I cross again twice, I'm back where I started. I'm not over there, right? So we can't cross twice. It's impossible. It's impossible to cross twice, right? If anyone can do that, show me. But I don't think you can cross twice, because crossing twice means I'm back on the other side, right? I can do this, but that's not crossing, that's just touching, right? That's like saying going across the river and then going back to the river, putting one foot in and coming back. That's not crossing, right? So we can't. So we can't cross twice. Can we cross 3 times? Yep. Back, forth, right? 1, 2, 3. Can we cross 4 times? Let's see. 1, 2, 3, 4. I'm back on the other side. Has to be 5, right? It's part of a function, right? It's on how many turns, right? Okay, so yes, so it does apply. So where is it going to cross? That's the question. Where is it going to cross? So I need the x coordinate here. So what am I going to do to get the x coordinate? Yeah, since it's a quadratic, I'm going to factor. That's the only option I have. Either that or quadratic formula. But hopefully it factors, so I don't have to use quadratic formula. Most of the time it will factor. What do we get when we factor? Those of you guys, I'm sure some of you guys have already done this. What do you guys get? X minus 4 and x minus 2? Yep, that works. So where is it going to cross? At x equals what? 4 and x equals 2. Wait, didn't we just say it can only cross, it can't cross twice? What the heck happened? We said we can't cross twice, right? We can cross once, we can cross 3 times, I can cross 5 times, but I can't cross twice. Why did I get 2 x values? I didn't do anything wrong. I did it's right. But why is it not wrong? What's the only one that we need? What's the only one of these that I really care about? Which is? Yep. That one doesn't apply. That one doesn't apply because it's not within the intervals. It's not within the intervals. Okay. So 2, 1, it's going to cross right there. So how it looks, I don't know, but it crosses at 2. So C is equal to 2. Okay. These types of questions are very common on multiple choice. I'm trying to give you guys that hint for next week. The difference is it'll be a different function and it won't be f of c equals 0. It might be this. It might say f of c equals 3, f of c equals negative 4. Would that change how I solve the problem? No, it wouldn't change it at all. I would do it the exact same way that I just did this problem. Okay, it would do it the exact same way. It's just, like I said, that's the hard part about this class is Mr. Flores can't show you every single example to every single problem in a history of calculus. I couldn't do it even if I had 100 years, right? So the more comfortable you are with, okay, hit a wall, let me understand what I did. We did this problem and we kind of did this and I kind of did this, so that, you know, that thing, kind of thinking on your own, thinking on your feet, critical thinking. The students who can do that will be fine. Does that mean even if you hit a wall, does that mean you will get through the wall? Sometimes you won't. But most of the time, if you try, you will. Okay? If you use your thinking, put your thinking caps on. You're all very smart. That's not a question, right? This is the top of the hill. AP Calculus is the top of the hill, and you guys are here, right? So you guys have worked hard to get there. So you guys are all very smart. That's not a question. It's just being able to hit a wall and keep going, or just hitting a wall and kind of collapsing, right? So that's what I empower you guys to do. Okay. Okay. So what I want you guys to do now is